Hi, it's Corey. I want to walk you through how to run a ANFSatSolver using a variety of tools to break down AES into a CNF file or Dimax file that you can then run with the ANFSatSolver. So the first step is to get VirtualBox or some kind of virtual machine up and running software. So there's VMware and VirtualBox. I use VirtualBox, it's free. The link for that will be in this video and in the description below. And then you need to run sagemath, which you can download online and then install as if it's a virtual machine, even though it's kind of like an application. And the link is also in this video and in the description down below. So I went ahead and started that by clicking on the Sage virtual machine and clicking start. So then I have this virtual machine up and running, and you can interact with the virtual machine here if you would like. It's a lot easier, especially for some of the steps that I want to show you, to do through localhost. So I want to show you that real quick. You need to have your browser up and running, and then you can start by going to localhost 888. So we're going to go there. So the username and password for this is admin and sage. I don't know how this works to where you can get a localhost and it's running off the virtual machine, but it does. So I'm kind of just following their tutorial and teaching you. And if you want more instructions on how that works, follow the links in the description below. So I want to sign in right quick and show you this project, it's AES. So in that folder AES, the project AES, you'll need to upload the AES to CNF Python script. I was able to get that from a Bitbucket repository that I found. It's the same script that Crypto Minisat uses for converting and digesting AES instead of the CNF format or that Dimax format. So to upload that file, you need to go to Data, Upload or Create File. So you can do that. Click Choose File. I've already done this, so I don't need to upload it again. But what you would do is say this PDF file, say that is the Python script. You'll click that and then click Open. You can describe it if you want, and then just click the button Upload. So like I said, I don't need to do that, so we're going to go back to the worksheet. What this is right here, this right here references that Python script. Data just says, you have that data somewhere. Okay, and then what's the file name, and then you type in the file name. And that link, of course, is, as it says in the description below, and I have included it in the project submittal. So the rest of the script is what I wrote in a combination of what I found from the DES, which is the lesser form or the prior form of AES, and combined with the ANF to CNF conversion script, and then saves that locally as a file. So right now I want to do the smallest form of AES just to crack for testing. So we're going to do 1, 1, 1, 4, and then down here we're going to save that as 1, 1, 1, 4. Okay, cool. So once you've typed or copied this script in right here, you'll click the word evaluate, and then you'll see this text file right here, AES CNF 114 text, and this is your CNF file. Minisat and Crypto Minisat have no problem with comments. Walksat does, so you either have to manually go through and delete all the comment lines, or write a bash script or something to delete all those lines. And either way, the bash script is included in the project submittal as well, so if you need that, feel free to use it. So you can save this file either from going here, save as, or just clicking Control S, whatever it may be, and you can save it right there as your file. Okay, and then you click save, and I don't need to replace it because I already have it there, but that's it. And then you can copy that to a thumb drive, and in the next portion of this video I'll show you how to copy that into Linux and then run it using Minisat. Okie dokie. Hi, so I want to tell you how to get that CNF file that you created earlier from the sagemath application, I guess you can call it. And then now we're going to show how to copy that file over, run it using Linux. So I'm using Kali Linux. I'm sure you can use Ubuntu or any other Linux-based operating system. There's also other ways to copy files. This is just how I prefer to do it. I will begin by adding a device. I just have my cruiser running, so I'll click that. You'll see eventually a USB drive is now shown on the virtual machine. You can open that, take the file, and add it wherever you want. So for me, I am going to add this to user local sat. So now I have that. I have the AES CNF right there. That's just the file, and I have the suffix. And this is explained in the report for what these four numbers mean. But this is just the easiest version of AES to solve. So we'll go ahead and try to solve that. I'm going to assume you know how to run and install minisat, as well as the other sat solvers, and if you don't, that is included in my report in the appendix. So we are in that user local sat folder, so I can see that there is the AES file right there. So I want to run it using this command. A note is if the runtime is so fast in minisat that it won't account for that short time, so I put the prefix, the word time, right here for runtimes that are relatively small. So if I run this, I get, see, it doesn't even show 0 seconds, but it'll show the real time is 0.06. So that's what I used. So now I'll plug that into my Excel spreadsheet. So I want to add this into the display so you can see what I'm talking about. This is what I had running, or what I used for benchmarks when I was running this originally. So I want to run this a few times and copy the times over. So for instance, we had 0.006, so I want to add that in. 0.006, and so you'll see over here I have the prior average, which is run from 10 runs, and included in the report, and this is going to be the new average we're going to calculate, and this is our delta. So it might be a little different, and we'll see that. So let's run this again. So I'll run it again. 015, 004, 005. So 0.015, 0.04, 0.05, and then now let's get one last one. 0.004, 0.004. So we can see our runtime with the test set that we just ran is significantly almost to 0. Is not significantly different, it's a little bit different with a 0.001 difference, but that's about how I got the average runtime. And I'm sure if we ran about 100 test cases and averaged those numbers, it'd probably be a realistic number. I just ran 10 cases for each. I will say that I will not show how to get the, oops, I'm not closing the wrong window. I won't show how to operate and run and install walksat and cryptominisat just because the instructions are available online and I don't want to take up too much time with this video. So all the links and descriptions of what I talked about is included in the video below, or the description of this YouTube video below. So feel free to take advantage of that, or email me or message me through my UCF as needed. All right, thank you.